Second day of math traps. Very exciting. 3 more traps after the 3 from Tuesday. So let's look at ratios of ratios of ratios. So here's the trap. Ratios don't always refer to the same numbers. Best way to do this is get a common denominator and make sure everything lines up. And you'll see what I mean here in a second. The trick here is to make sure that the numerator and denominator kind of refer to the same item. So here's an example. Ratio of W to Y is 4 to 9. So as you can see, I wrote 4 for W, 9 for Y. And then the ratio of Y to Z is 6 to 5. A little tricky here. You'll notice the order switches. If I'm going to then compare the ratio of W to Z, I want W and Z to be in the same location. So notice they are both in my numerator. That means that Y is both of my denominators. So let's get them to be equal denominators. So because we're going to kind of compare these fractions, and we want to see how W compares to Y and Z compares to Y with the same Y's. If I can do that, I can answer this question. So looking for a common denominator, looks like it's going to be 18. So that means I multiplied 9 by 2, which gives me 8 for W. And then 5 would be multiplied by 3, since 6 to 18 is 3, so 15 for Z. So that would be 8 to 15, answer A. So the next trap is belief in positive integers. The trap we're falling into here is that if we have to test out a scenario, it's pretty easy for us to just choose small positive numbers like 1, 2, 3, when really we should be testing ridiculous, obnoxious numbers. So if I'm going through and I'm asked to test, the way I'm going to do this is I need to test more than one scenario and I need to cover all my bases. So what that means for me is I need really big positive numbers, really big negative numbers, and then also fractions. So the thing we forget to try that sometimes reveals an answer for me is trying fractions. We want to choose things close to 0, so less than 1. Because that's what can really mess up a scenario. So let's say I'm given this question. It says, if x is any value not including 0, so I'm not going to test 0. 0 is a pretty easy choice. That's why they remove it. So not including 0, which of the following are true? So looking at my options, clearly 1, 2, or 3, or a combo of those is true. So I'm just going to start testing. So I choose obnoxious numbers. So let's say for number 1 here, I choose 1,000. So 1,000 plus 1,000 is greater than, if I subtract that real quick, yeah, that's true. 2,000 is greater than 997. Let's try an obnoxious negative number, though. So like negative 1,000 minus 1,000 is greater than negative 1,003. I don't know about that. Negative 2,000 is not greater than negative 1,003. So that's a problem for me. I can't use that. So that's not true. So that means for me, first of all, A is out. Only 1 is true is not accurate since it's not true at all. But it also removes D as an option. So I'm saying if 1 and 2 are true and I just found out 1 is false, I'm going to make sure, scan my options and make sure that I get rid of anything that has 1 as a possible answer. So now I'm going to try some numbers with 2 until I'm satisfied. So I'm going to choose a really big number. I would say 1,000 squared is greater than 0. That's true. Where I want to be careful is this. They're asking you to square x. So whatever you choose for x, you have to square the whole thing. This is also positive. That's a positive number which is greater than 0. So when I plug in a negative, I'm still getting a positive number. So I tried a big number, an obnoxiously big positive number. I tried a big negative number. They've worked so far. I'm going to choose a fraction, say a half. Yeah, it looks like it. All of these are going to work because anytime I square a number, and because of this scenario right here, any negative is going to become positive, any positive is going to stay positive. Those are all bigger than 0, so 2 is in. So 2 looks good. So B and E look good. They both have 2 involved. But now looking at option C, it says only 3 is true. Well, I can't be anymore because I just found 2 to be true. So I finally narrowed it down to B and E. So I'm looking for something to not be true for 3. I'm looking for a bad scenario here. So if I plug in, I'm going to get less obnoxious. Let's plug in 10. 10 cubed is definitely larger than 10. That's fine. When I go to do negative, however, I get negative 1,000 is greater than negative 10. That is definitely not true. So 2 and 3 being true is out, and that means my answer must be B only. So be careful, make sure you plug in obnoxious numbers to make it even more obvious to yourself. Would also fail for that last one, by the way. And the last idea is counting is hard. Pretty easy for us to lose track of things. Let's say I want to know what are the numbers between 1 and 4 inclusive, meaning include 1 and 4. You would say, how many are there? There are 4. 1, 2, 3, 4. That's pretty easy. But when we get in a hurry and we subtract to try and answer something like that, so for example, 10 to 20 inclusive, how many numbers are there? It's very easy to say 10. We take 20 minus 10 and we get 10. However, that's wrong. There are actually 11. Don't believe me, you could count it out. I'm not going to do that here now, but there are actually 11. So here's the idea. If you are subtracting the bottom and top of a range to try and find out how many objects there are, if they're numbered, between those two numbers, you need to add 1 to the number you get. And the trick here is not to hurry. It's pretty easy to lose track of what you're doing. So let's say we're at Trefzger's. I'm excited. We pull a ticket with a number on it when you come in the store so that they can serve you better. If the first number pulled in the day is 12 and the last is 254, how many customers did they have that day? The trap here is to subtract the two and you go, okay, well that's 242. Yay, I'm right, but you're wrong. You didn't include 12. You don't really count that first number when you subtract two numbers. It's actually that plus 1, which is 243. So be careful when you are looking at a range of numbers. You need to make sure that you include the first one that's counted. So do add 1 when you subtract.